So here we're doing algebra functions. And so algebra functions, I'll move my mic closer because I'll probably be a little quiet today. Algebra functions. So here, if you can take two functions, and here I'll represent, and here we have examples of like two different functions, f and g are the following. And so given these two different functions, we can add them up, right? So you can actually add functions together. That's nothing really all that special. You're just adding one function to another. We can minus one function to another. We can multiply one function to another. And the domain of the corresponding function will be the intersection of the domain of A and the domain of B. So everything that it has to work both in A and B. And that makes a lot of sense because if it doesn't work for a part of it, it's not the whole function will fall apart. We can also divide functions, but we also have to make very clear that G, our function on the bottom, is not 0 because we can't divide by 0. So let me slowly work through an example. This makes more sense in an example than everything else. So let's first deal with the domain. The domain of this function is, what's the domain of f? Are the domains attached to f and g? Yeah, let me explain it in an example, and that should help. Apparently there's a tree cutting crew going on right outside my window. Of course, right? So for f, my domain here is all real numbers. Yeah, someone has it. So here's the domain of f, which I'll say A, is equal to all real numbers, right? And the domain of g, since this is a polynomial, again, is all real numbers. And so here we said the domains A and B, so all real numbers. The intersection between all real numbers and all real numbers is, again, all real numbers. So A intersection of B is the same as all reals intersect with all of the reals, which is all the reals. And so the domain for, let me put it down here. Okay, let's just put the domain is all reals. And that's the same here and here, right? So for this one and for A and B, it's all real numbers. The other one that's slightly interesting here is G, because the domain for this one, let me put it down below so I can work elsewhere. So the domain here is all the real numbers, whoops, but I have to throw away where G is equal to 0, right? G cannot equal to 0. So here I'm just going to solve real quick, which is, whoops, what is G? X plus 4. So I have X plus 4 not equal to 0. Oh, 0. That means X is not equal to minus 4. So the domain here would be from minus infinity, negative 4, gamma, union, minus 4 to infinity. Okay. So I just have to throw away the 1. And your computer program likes to put it in interval notation. And so the domain here, this one's less interesting. The one on the next page will be more interesting. So the domain for the addition, the subtraction, or multiplication is just going to be all real numbers, because this function can take all real numbers and this function can take all real numbers. And so adding, subtracting, multiplying, all real numbers. This one, this algebra function here cannot divide by g, and so here I have to get g cannot divide by g when g is 0. Let me be very clear on that. And so when is g equal to 0? Well, when x is equal to negative 4. So I have to throw away negative 4. So it's all real numbers except for negative 4, and that's just how you write that. Okay. All right. So let's actually we're going to do the first part first. So I'm going to do the x part, and then we're going to do the 3, and I'll do the 3 separately each time, okay? All right, so we have the domain. So when we add a function, f of g of x, here we're just going to take the f of x, so f of x plus g of x. Well, what's f of x? Well, it's right here. X squared minus 4. What's g of x? Plus g of x, which is x plus 4. And that's it. That is literally it. I mean, we could simplify, sure. We can get rid of we can just have it as x squared plus x, right? But just go ahead. I guess let's go ahead and do that for this one. It's x, because then I can just cancel these two. And so f plus g, the function of f plus g of x is just x squared plus x. If I minus the two functions, the function of f minus g of x is just the function of f minus the function of g, which is equal to f of x squared minus the quantity of x minus, or x plus 4. And the reason I'm doing it this way, in parentheses, is that way you can see clearly that this negative goes into this one and to this part. And so it'll be x squared minus 4 minus x, and then minus a 4 again. And so here we have x squared minus x minus 8 is our function. Okay, and then f of g of x is equal to f times g, which is equal to x squared minus 4, x plus 4. Here we're going to FOIL because we have a polynomial. So let's go ahead and do that. So the first would be x squared times x will give us x cubed. So my first, my outside is x squared times 4, so plus 4x squared. My inside would be negative 4 times x, so it'll be minus 4x. And my last is negative 4 times positive 4, which gives me minus 16. Okay, and so that's our function right there. I'm supposed to distribute the, hold on. Is that a equal to, so here this is a equal to all reals, and this is all real numbers. Let me just catch up on the questions. Are you supposed to distribute the x? Oh, this x? No, this is, let me see. I see what you're saying. I see what you're saying. Let me see. So let me see if I can, be clear on this. So I am using f and g when it should be technically the function of f with respect to x plus the function of g with respect to x. This is a good question. And so I say f plus g, these are the same. I'm just leaving off the g. And so if I say f plus g, I'm saying this is the function, right? This is my function f plus g. And so I could technically recall that like h. And so what I'm doing here is I'm saying the function of f plus g with respect to x is kind of like a function h of x. It's and so the x here is not multiplication, it's a delineation of what went into that function. And so it's kind of because this is the same as h. It's just saying what goes into h. Because technically when I write y equals mx plus b, this is y is a function of x. So it would be y function of x equals mx plus b. And I can see how that can be confusing. When is this multiplication or when is this a function delineation? It gets a little weird. Okay. Oh, I see what yeah, I think I know what you're talking about. Hopefully that clears up that. So, all right. So let's go. So here's this, and then we'll do the last function delineation here. So f of f divided by g of x. So this function f divided by g of x is I'm going to take f divided by g. Well, f here is x squared minus 4. G here is x plus 4. And we can just leave it right here. Nothing else we need to do here. And so We're good to go. So now let's plug in the values of the function. So here, I want to find out what happens if I plug in 3. Well, there's two ways of doing this. There are two ways of doing this. Let me show you both ways. Let me show you both ways on one, and then we'll kind of default to one way on the others. So here, I can just plug it in directly. So if I wanted to find out what f plus g of 3 is, well, I know what x is, right? If I plug in x, I'm going to get x squared plus 3. So if I plug in 3, I'm going to get 3 squared. Put that in parentheses just for good measure, plus 3. Well, 3 squared plus 3 is 9, plus 3 is 12. Okay. And I can do the same over here. Here I can have 3 squared. And I can plug it in directly here. So if I plug in f of 3 here, I'll get, or f minus, oops, hold on, I'll go back. I forgot my minus g of 3. Here I can plug it into this function. And so here I'll get 3 squared, which is 9, minus 3, which is 6, minus 8, which is negative 2. And so there we go. But another way of doing this is I can figure out what f of 3 is, right? So f of 3, if I plug 3 into this function, I'm going to get 3 squared, which is 9 minus 4, which will be 5. And if I plug 3 into this function, I'm going to get 3 plus 4, which will give us 7. So g of 3 is 7. And f of 3 is 5. And then I can just literally add 5 plus 7, I'll get 12, and I'll take 5 minus 7, and I get minus 2. And so in this case, we could plug 3 into this and calculate a number, but we're not going to. We're going to just find out what f of 3 is. We're going to multiply it by g of 3. And so that's 5 times 7. And so that's going to give us 35. Now, in my other class, I typed this in the calculator. And if you crunch it through a calculator, you'll get 35. And so this is the same, right? So doing this is the same way. And so instead of doing it the complicated way, we're just going to do it the easy way for this one, f of g of 3. We're just going to put in 5 over 7, and we're done. So that's all we need to do for this one. Okay, go ahead and, oops, hold on, there we go. I hear someone clearing their throat in the background, so let me clear that out. All right. Oh, do you guys need this up for another 2 seconds before I move? Let me leave this for a second. Okay, I'll post the video probably for this class. I think for some reason, I think it's just going a little smoother, and I'm explaining things that when I did it last time, sometimes you haven't taught a subject for a while, you forgot, oh yeah, that's not as obvious as you think it is, right? You've been doing this for a while. You ever have someone explain to you and it's like, oh, it's real simple, and they just like do 5 things and you miss like 10 steps. You're like, okay, dude, you forgot what it means to be a student again. I think we've all had that experience. All right, so let's do this again. This is getting confusing. I agree. It seems confusing until you just kind of crunch through it and give it a try. So let's do the next one. Yeah, if you miss 2 minutes of rocket science, it's just how math is. If you like go to every other class, like your philosophy class or literature class, you miss 2 minutes, you're like, oh, okay, and you like pick it up because they'll like change subject. But math is completely built on each other. It's kind of like building, see, math to me is like building a tower, right? And you just build up each little level on your tower. But the problem is if you miss a little bit, somewhere in your tower you have just like a missing link. You're like, oh, you can still build for a little while, but eventually it's going to get top heavy and collapse because you missed this link. All the other classes, if you're like missing something, it's not really built on that. And it's kind of like it's like laying tile, right? And you're like, oh, you have like a little hole in your tile, but that's okay, right? You can come back and fill it in later, right? It's like, oh, I figured it out, and you can fill it in. But It's not the same with math. Math's all built on each other, and so if you miss a bit, it just all crumbles. Anyways, let's get rid of my little analogies and let's teach math. That's what makes learning math a little bit more difficult. So let's do this. So let's do the domains first. Let's do the domains first. So the domain of this function, just as a reminder, is this has to be zero's okay inside, but a negative number is not. So I need x plus 1 to be needs to be greater than or equal to 0. And that means just x has to be greater than or equal to -1. And then here for this one, I can have everything except x equal to 4, because I can't have this equal to 0. So x minus 4 cannot equal to 0. That means x cannot equal 4. And so if I was going to put these two together, how would I do that? So someone put it in chat, like what would it be? In fact, just to make your life slightly easier, oops, that's a not equal sign. Let me write this in interval notation. So this is from, let me write this in interval notation. So this is bracket, -1 to infinity is okay. And then this one is minus infinity to 4. We throw away 4. So not including 4 to infinity. That's how you throw away a single number. And if I want to take the intersection of these two things, do you guys know how to do that? And if you do, go ahead and put that in chat. See if one of you can figure out how to put that in chat. Yes, that's actually very correct. Thank you. And so that's how you write it. It's in chat, but I'll put it on the page because chat won't be on the video. So here I'm going from -1, and then this is then everything up to that's in both until I hit the 4. So I need to throw away 4 union 4 to infinity. Okay. And so that's how you build this. And so if we're looking at a number line, let me just do this on a number line because I haven't really reviewed this too much, and then we'll finish with the math. Here I'll have -1. We'll have 0, and then we'll have 4 here. I'm going to do this one in pink. So it'll be brace, -1 all the way into infinity. And then I'll do this one in green. And so this would be, looks like this, right? And if I was going to put this together here in, I don't know, the soft color, it'd be where it's equal to each other is this one all the way up to the 4, and then here onward. And so it's just where these two overlap, if that helps you guys. Why is there a bracket? Oh, because I can't have the -1. The -1 is allowed. If I put a -1 in here, I get 0 and it's okay. And so I put a brace right here saying it can equal -1. Okay. Thanks for answering the question. Okay. And so here, if I put these two together, it's just where these overlap, and that's how I draw that in. Then I retranslate that up to this. Okay. All right. But however, I'm not going to leave this on because I need the space to do the math. All right. So I'm going to do the first one with you, and I'm going to have you guys try B and C, and then we'll do D together. All right. So here, I'm going to have f plus g of x. I'm still in my happy fun purple. Can we get a little darker color? Nope, that's not what I wanted. Let's do a little darker color for a second. So I'll have f plus g of x. And so that's going to equal. Oh, let's make our lives a little bit easier. What's f of 3? So f of 3, if I plug 3 in, I'm going to get 3 plus 1, which is 4. Square root of 4 is, of course, 2. And then f of 3 for, what's g of 3? Go ahead and put that in chat. What's g of 3? -1, yes. And so that's -1 because I'll have 1 over -1 because 3 minus 4 would be -1. So 1 over -1 is just -1. All right, so if I was going to do this, it would just be x plus 1 plus 1 over x minus 4. And then f of plus g of 3 is just equal to f of 3 plus g of 3, which is equal to 2 plus the -1, which of course is just 1. Okay. All right. Since this is kind of rough, the type, just do C for me. Just go ahead and do C for me. Do both, and then this one's a little bit rougher to type, and then I'll have you guys do another one in a bit. So get what f of f minus g of x is, and then what f of f minus g of 3 is. Just give it a try real quick. And I'll wait until I have a couple of things in chat. I have a question. Why does A equal 1? Where do you see A equal 1? I'm a little lost. Where do you see that? I don't know how to type this, but I think it makes sense. Yeah, it makes sense. On the bottom line. At the bottom on the left. On the left. Oh, why does A equal 1? Thank you. Yeah. This A. Why does question A equal 1? Man, my brain's full of guacamole today. Because here, f of 2 is 2, and g of plus a -1, because g is -1. Sorry, that's fine. Question 8. Yeah, I picked it up. My brain picked it up really, really slowly. I can do high functioning math and simple questions. I'm out of it. I'm sorry, guys. I haven't typed out of it today. All right, so let's. We have lots of answers, and they all look mostly correct. Oh, someone did all the 3s. Yeah, so let's go through this. So f minus of g of x is just equal to x squared, square root of x plus 1 minus 1 over x minus 4. And then here, if I add f minus g of 3, it's just equal to 2 minus a 1, which gives us the 3, because it'll be f of 3 and g of 3. Same thing here. If I multiply the two functions, I'll just have square root of x plus 1 multiplied by 1 over x minus 4. You can simplify this if you want to x plus 1 over x minus 4. Hi, can that look more like an x minus 4, please? Thank you. Here, if we take f of g of 3 is equal to f of 3 times g of 3, which is equal to f of 3, of course, is 2. G of 3 is -1. And so I have -2. Here, for d, we'll do the same thing. So be f of g of x. And so here I'll have square root of x plus 1 over 1 over x plus 4. If I have remember compound fractions, I can flip and multiply. And if I flip and multiply, I'm just going to get square root of x plus 1 times the square root times 1 over x plus 4 is just x plus, or oops, that's not plus, is it? Sorry, guys. That's a minus. X minus 4, and then this will be minus 4. But notice here, well, g can never be 0, right? This has no capability of being 0. But notice here, if I took the domain for this one, it would be different. So it has to be the pre-simplified one before you take the domain. And so every A, B, C, and also D in this case, because this can never be 0, all have this domain. Even though this, when you simplify it, looks like you can have something simpler, but since you've done the operation, you cannot, since the operation was done, it had to have worked here. Okay. I know it doesn't, what I'm trying to say doesn't make a lot of sense, which I guess don't worry about it. They ask you the domain like twice, and you just say, if it doesn't work, it doesn't work in your homework. And so f divided by g of 3 is equal to 2 divided by -1, because that's what, and then we get minus 2. And once again, the 2 comes from f, and the -1 comes from g. All right, so let's go ahead and do this. All right, so let's do, so let's plug in other things into a function, and then we're going to get to the difference equation, which we'll be using a lot. This is what you see in calculus. This is a limit. You just don't know it yet, and how to take a derivative. So they'd love to ask this question. So let's go slowly through it. Let's build up different parts, and then we'll put it all together in a simplest way possible. And then I'll have you guys do one, and then I'll do a complicated one with you guys, and that would basically be class. So let's get to there. All right, so let's do, so f of minus a. So f of minus a means everywhere I see an x, I'm going to plug in minus a. So it'll be 2 minus a squared plus -a minus 1. And here, f of -a, or minus f of a, is I'm going to take the function f of a. So here, I'm taking the entire function 2, and then I'm plugging in a into the function, and then I'm negating the whole thing. And these are two different, they come out with two different answers. So I'm going to do a, I'll have you guys do c. So a becomes a squared, or -a squared is just normal a squared, plus, oops, that'll be minus a minus 1. So go ahead and try c, and just type that into chat real quick. All right, I got one, someone else. Oh, we got a bunch of answers. All right, so here I have minus a squared. Oh, I forgot my 2. Sorry. Let me put in the 2. 2a squared minus a plus 1. Okay. And so notice that these differ by a couple different signs. Here of f of a plus h, let me be very clear. I'll do this one. F of a plus h. And plug in a plus h. So it'll be 2 f of a plus h squared plus a plus h minus 1. And so here it's 2. I'm going to write this out. You don't have to write this out, but I want to write this out to be very clear on something. That a plus h squared is not a squared plus h squared. It is, we have to FOIL this. So let's FOIL. And so here I'll have 2 times a, so a squared, plus AH plus another AH plus H times H, which give us H squared. So first would be A times A. Outside would be A times H. And the other one would be H times A, which is the same as A times H. And then the last one is H squared plus AH minus 1. We'll just distribute in the 2, and then we're done. So it would be 2A squared plus 4AH, because I'll add this up to be 2AH times 2. Plus, oops, I forgot my 2. 2H squared plus A plus H minus 1. All right, now that we have this, we can do D fairly simply. Do I have what f of A plus H is? Yeah, it's right here, right? Do I have minus f of A? Yeah, it's right here. And so I can just put these two together. So it'd be 2A squared plus 4AH plus 2H squared plus A plus H minus 1 minus 2A squared minus A plus 1 all over H. So here, this right here is the f of A plus H. This is my minus f of A. And notice here we can cancel a lot of things. I can cancel this with this, because that's a positive 2A squared and minus 2A squared. I can cancel this with this, so this would be minus A and plus an A. And then I can cancel negative 1 and plus a 1. And so what am I left with? Well, I'm left with 4AH plus 2H squared plus H all over H. And I can simplify. I can pull an H out of each one of these, so I'll do that. So I'll have 4A, pull the H out, plus 2H, because I pulled one of the H's out, plus 1. And then I'm going to have to multiply it by H. And so does this work? Yep. 4AH, 2H squared, plus H. So you can just quickly check if you did it right. Divided by H, and then you can just cross off the H's and you get what you need. Plus 1. We'll do more practice of this definitely before the exam and stuff. And so this is how we achieve and do this. All right. So let me leave this up for a second. Just out of curiosity, how's the exam formatted? Exactly like the homework. Some of your test 1 exam questions are literally carbon copies of the homework questions, just you only get one try and you don't get the help me solve, you don't get the view an example, you just have to do it. Why is it over? Oh, okay. So the question is, why is it all over H? So here, let me circle what's what real quick. So f of A plus H is this. Let's go ahead and use this. Minus f of A is this. And so here I plug these in here. So this is my f of A minus H. This is my A minus H. And then here, this H here is here. And so here I'm just expanding. This goes there, and this will go over H. Do that. Is the exam open? No. Can I scroll up, please? I can scroll up for a second. I'll just zoom out for a second as I answer a few questions. There we go. Is the exam? Yeah, it's open. No. Do you take? Yeah, well, the exams currently the department just declared all the exams are going to be through the Pearson website until things change. Okay. And so what they currently have it set is that you can take it anytime you want, but once you start it, you have 75 minutes to complete it. It's 15 questions, and so that gives you, what, 5 minutes a question, roughly? Yeah, 5 minutes a question. According to Pearson, some of them only take the student 30 seconds, right? I'm going to see what the official, we'll have a department meeting before you give it. You get one try, so type it in correctly, and then you get 75 minutes. I'm going to see if we can just give you guys an extra, if I'm allowed to give you guys a little extra time and 2 tries on the problem, just in case you type something in wrong once. But it's actually not too terrible if you only get 1, because then I can manually review it. But it's 15 questions, 15, 1, 5, 1, 5, 1, 5. Well, it is the homework questions. It's literally the homework questions. It's like, it'll be some of them, homework questions with no different numbers, and some of them homework questions with different numbers. That's it. You just don't get 25 tries. You don't get all the extra help, and it's timed. That's the only difference. We have a whole week of study for the exam. I'll grab those 15 questions. You'll do a lot of questions very much like them. Okay. We'll do practice together in class. You'll do exam together on the discussion boards. So basically, how the exam works in my mind is the Monday. Monday we do one together in class, right? And I'll do it with a video, and then you'll do one on the discussion boards, right? And so your discussion questions will be due earlier that week. We might be due like Wednesday night, and then like Thursday morning, I'll post the answers to the exam, even though you guys are going to do all the answers, right? For the other practice. I don't know if you guys are doing all the answers. I may not post it. It's like I'll just check through the ones in the discussion, make sure they're all correct. And then Thursday we won't have class because that'll be your exam day, and then you'll just take the exam that day. Does that make sense? And that's not next week, but the week after. Trust me, it'll be all very clear what we do before we do it. Okay? All right, so let's do this. So I'm going to have you guys do this one, but I'm going to have you guys do it in chunks. So here, find what f of a plus h is. Find out what f of minus a is, and find out what minus f of a is, and put this in chat. So do these two and put it in chat, and then I'll have you guys do this one. So if you're I do not need to rewrite that. So put this in chat, try to get the answers, and once you have those, we'll go from there. All right, I have one person with answers. Okay, seems like we got some answers coming. All right, so here, if we're just going to plug our f of a, so it would just be 4 times a plus h minus 5, and so this becomes 4a plus 4h minus 5. And then here, this is minus of f of a minus 5, which becomes minus 4a plus 5. Okay, so once we have these, we can put it together. So we'll put a minus plus 4h minus 5 minus 4a plus 5. Okay, and so go ahead and see if you can't solve this one now. Solve it all the way through. All right, 4. All right, so yeah, so we cancel this one. We got a lot of, oops, wow. This minus 4a and this a, this and this, and then I'm left with 4 over h, which is equal to 4. All right, so I'm going to do this one with you. This one's a little bit more complicated. I got 23.5, somebody's just messing with me now. All right, so I'm just going to go ahead and plug this straight in. So here, f of a plus h, so 1 over x. So f of a plus h would be 1 over a plus h minus f of a, which would be 1 over a all over h. And so if I was going to solve this, if I was going to solve something that looked like this, what must I do? Well, I must clear out the complex fraction up top. In order to do that, I thought you had to subtract. Oh, so yeah, so up here, we've already pre-subtracted it with the negative. If you leave f of a here, if you found just f of a, you would have to subtract it. But here we're finding minus f of a, so we're just adding it, right? Okay. So what do I need to do? I need to clear out this fraction, so I just need a common denominator. So I'm going to multiply both top and bottom here by a, which is a 1. A over a is 1. And then I'm going to multiply by a over h over a over h. And so after I do that, we can go ahead and go to the next line, which would be a of a plus h minus a plus h over a plus h all over h. And then we can simplify. So it'll be a minus a plus h over a plus h over h. So here, I'm just multiplying. So a gives me an a, this gives me an a plus h. If I add it up, oops, what have I done wrong? Gotta be careful here. This negative goes here and here. Okay. So a minus h. Okay, so the a's cancel. And so here I'm left with minus h over a plus h. And then if I divide, if that's the same, this is the same as that. Here I can cancel the h's, and I'm left with my answer, minus 1 over a plus h. And so this one's a little bit more complicated. I don't think we ever actually do anything this complicated, but the book goes over it. And so I thought it'd be good just to see it once. We will be simplifying complex fraction. Can I explain the top part of 5? Sure, let me explain that real quick. So f of a plus h is this right here. F minus, and then f of a is this right here. So it'd be f of a plus h minus f of a, right? This is f of a, because it's 1 over x, right? Then, in order to put it together, because there's no way to put it together, I need to have a common denominator for this fraction. So the easiest way to do it is I just take what's over here and multiply it by top and bottom. Why does the h cancel out? Oh, here? Well, let me go over this real carefully, and then I'll explain. We'll get to that. And so I want a common denominator. And so now I'm going to multiply by a over a. Why? Because that's going to make this a times a plus h. And here I'm going to multiply by a plus h. So I'm just multiplying this denominator on the top and the bottom. And I can do that because a over h plus a over h is 1, right? So I can multiply anything times any number times 1 is that number again. So if it's pi times 1 is that as pi, right? Or 1 over a times a over a is still just 1 over a, right? Because here a over a is of course 1. And so here I'm using that property to get a common denominator. So I'm going to multiply this denominator to both top and bottom of this fraction and this denominator by top and bottom of this fraction, of the other fraction. Once I do that, I get this, a, and then a plus h minus a plus h divided by a times a plus h. And then what I did is now that I have the same denominator, I can put this fraction together. I distributed my negative sign to both. And then here I can cross off a and minus a because those will add up to be just a. So I'm minus h. And so minus h over a plus a. But notice that if I divide phi h, it's the same thing as multiplying by 1 over h. And so here I have an h on the bottom. I have an h on the top. And since I'm multiplying, I can cross it off. And then I'm just left with negative 1 over a plus h. Okay. All right. So that's the end of the notes. You'll have the homework to crunch through. The homework looks a lot like the notes. You're just going to add stuff up, make sure it's in its domain. You're going to do quite a few. You do not quite a few, but you do like a couple of these where